In this problem, we are going to compare the values of log base 3 of 2, log base 4 of 3, and log base 5 of 4. So instead of comparing all three values at the same time, we can compare them two at a time. So we can start with log base 3 of 2 and log base 4 of 3. To compare them, we can take their quotient and compare it with 1. If the quotient is larger than 1, then the numerator is larger than the denominator. If it's smaller than 1, the numerator is less than the denominator. So log base 3 of 2 over log base 4 of 3. This equals to log base 3 of 2 times 1 over log base 4 of 3. We got it into this form because we have a formula called the base switch formula to take the reciprocals of logs. This equals to log base 3 of 2 times log base 3 of 4. So now they have the same base, but we want to compare this with 1. So we can let these equal to x and y respectively and see if we can find out the range of xy. Xy appears in a perfect square formula. So if we take x minus y squared, x minus y squared equals to x squared minus 2xy plus y squared. And then, when I find the range of xy, we know that x minus y squared is larger than or equal to 0 by the properties of perfect squares. However, we don't know the values of x squared and y squared. Instead, we can use the other perfect square to help us determine the range of xy. X plus y squared equals to x squared plus 2xy plus y squared. So we can subtract 4xy to get x minus y squared. And then we did this so that we can take advantage of the range of the perfect squares, which is larger than or equal to 0. So we have 4xy is less than or equal to x plus y squared. And then we know the value of x plus y already. X plus y squared equals to log base 3 of 2 plus log base 3 of 4. Since they have the same base, we can apply the sum of log. So this will equal to log base 3 of 2 times 4, which is 8 squared. So we have xy equals to log base 3 of 8 squared divided by 4. Now, how do we compare this with 1? Log base 3 of 8 is pretty close to log base 3 of 9. And we know that log base 3 of 9 equals to 2 because 3 squared equals to 9. And then we know that it's supposed to be xy is less than or equal to log base 3 of 8 squared divided by 4. And we know that this will be less than log base 3 of 9 because by the property of logarithms, if the base is larger than 1, then as the x value increases, the y value also increases. So since 9 is larger than 8, this fraction will be larger than this fraction. And then this will equal to 2 squared divided by 4, which equals to 1. So we have xy is less than 1. This will mean that log base 3 of 2 is less than log base 4 of 3. Using the same method, we can prove that log base 4 of 3 is less than log base 5 of 4. So that is how you solve this problem.